Thanks for that introduction. Yes, as Fida mentioned, I head up a data science and product team for bond risk management. We build, and I will share some screen here. Let's see here. Let's get this in presentation mode. Too many things in front. There we go. Okay, yeah. So today I'm going to share with you a bit about how we do data science in my team and what that means, what that kind of looks like in the real world. Often people think about data science as sort of one task, but it's actually quite a range of different activities, at least in how things work in my team. So first, I'll just quickly start off a little bit on what the product is that we're trying to, we build these data science models for. So the bond and risk management family, our goal to make, the digital world fast, safe, and seamless for everyone. And so we have a set of products hopefully you've heard of before: bot defense, account protection, authentication intelligence, data intelligence, and just last week we launched a new mobile application shielding product. So today I'm going to focus mostly on the account protection product. That's where we do the most interesting, sophisticated types of data science. Bot defense, authentication intelligence also involve unsupervised models, decision tree based data science, and lots of really great work in terms of how we stop bots and authenticate people more quickly, but from a data science perspective, not as sophisticated. So anyway, account protection is a product that we've had for a couple of years. And how does it work? Either you're on a website, in which case we collect JavaScript, or you're in a mobile app, in which case we collect information from the actual SDK. We have a mobile SDK that our customers add to their application. And so these collect a set of signals. These are sent back to our backend engine, and in real time, these are processed by our what we call our rule and query engine that look at what those signal look like. We'll talk a moment about what those signals are. And then provide a response back, within hundreds of milliseconds, with a recommendation of allow, challenge, review, or block, and a score. Right. So this all happens in real time. There are other products or some scenarios where we help customers with offline recommendations. A lot of our competitors do offline recommendations. You can imagine a lot of fraud type of scenarios, like you order a product. Obviously, it's not great if they let you order the product, but if they figure it out before you ship the product, you can still stop the fraud, right? So no one loses any money. If you're in a bank account and I get into your bank account and take money or transfer money out of your bank account, then I really better figure out that I should not be transferring that money before the money's actually transferred. Otherwise, then they have to try to chase that money across other banks that you might have transferred the money to. So that's the type of places we do help: retail and banks, governments with tax filings, and as well as unemployment insurance and some other applications. But anyway, so the response comes back, and this comes back either in an encrypted cookie, or we inject it into the header. We run these services, our customers' traffic is proxied through us, so we see all their traffic between the website or the mobile app and the consumer. And they then, act on that recommendation or use it for further investigation, right? So there's a fraud team and or a security team who is looking, and doing analysis also on their side about the recommendations and figuring out where they think we might have missed fraud. Our product works best when they actually send us a fraud file as well. So either weekly or bi-weekly or monthly or quarterly, our customers, our more sophisticated customers, collect all the information about cases where they either think we got it right, wrong, missed fraud. So these are false negatives, false positives, as we call them in the machine learning space, and send that back to us in a file, right? And then that goes back into our ML training pipeline for to allow us to retrain the model to better tune it for the future. So that's sort of a little bit about the core of the account protection product. So what are some of the signals that we look at? We sort of characterize them into four sort of basic categories. There's network signals. So this is, are you using a VPN? What type of ASN are you using? What IP address are you using? As well as some aspects of your actual system, like the OS and browser, what type of graphics rendering infrastructure are you using? So for example, we have attacks happen. We had one last fall to one of our big bank customers that they were using emulated mobile devices running in a server farm. And so in that case, we can detect that because the rendering APIs that they're trying to use and the GPU that they're supposedly using, if you're on an Android device or an iOS device, you're going to be using very different graphics libraries than you would be if you're on a PC. And the CPU, GPU are going to be different. So you can actually capture some of those types of signals through JavaScript, and especially if you're on the mobile device through the SDK. The second sort of category is around the digital environment identity. So is the user agent that you're sending us different than the one that we saw before, has it been seen like 15 times? Are you replaying the user agent string to us? Are there issues in the user agent string, similar to I mentioned, between like the type of OS or browser that you're running and what we calculate from the device itself? So we see attacks where people will replay a user string to kind of try to fool a device ID, browser fingerprinting. It mismatches with the actual core information that we see from the browser or the device itself. You may see them saying the wrong time zone that also mismatches with the time being reported by the device itself, right? So often people who are attacking from, we had a retailer in the US who ships food to people, or allows people, I should say, a restaurant, and so you go pick it up. If you're ordering from Serbia, that they obviously don't have Serbia as a location, that's a pretty improbable time zone. The next sort of category are behavioral biometrics. So this is really things like how they're typing, the types of keys that they might be typing in, lots of function keys, controls, alt keys, and so on, don't really make much sense for someone typing in a password. Or some different form fields indicate that they're running things or doing unusual activity as they're typing things in, or it might be some kind of scripted, automated form filling scenario. You can see sort of how fast they're typing, how they're moving their mouse, how they're using their screen. So like, do they have the browser open in a full window? Do they have the browser in a tiny little portion of a window? Again, fraudsters are often, to be efficient as a fraudster, right? Because you should always think about what is the fraudster economics. And our goal is to make the fraudster economics too expensive for it to be, worthwhile doing the attack. And so if they can't sort of automate some of the work that they're doing, probably not going to have a high return unless they're doing an attack where, if you see like a spear phishing attack, you hear about, companies who've had someone in the finance department get an email saying that, the CEO is requesting that some purchase order has been approved and made like a $50 million purchase order fraudulently. Obviously, if they can pull that off, there's, that takes a whole bunch of different coordination. And none of these types of, well, a lot of the things that we have here may or may not catch that type of highly targeted attack, because again, we're kind of looking at general activity across lots of users hitting your site. So it's not so much, oh, Rupert Young is visiting your site for the 10th time, and every time he visits, I always use a Windows laptop running Windows 10. And I, have Edge browser and, Chrome browser 112 and something like that, right? There are competitors of ours who focus very much on that type of behavioral profiling. We look more at, again, something like, I've seen this device try to open 15 different accounts on this website in the last 5 minutes, or they've made 15 purchases in the last 15 minutes, or they're trying to make a $1 million purchase or something like that, and that's really unusual. Or when they went through the website, fraudsters, because they're typically shipping or transferring money to somewhere that you don't normally own, the normal behavior would be that I come into the site, I change something about your profile, like your shipping address, your email address, something of that nature, so that when when they make the transfer or make the purchase, and the site sends the confirmation that the email is to your email, or send the product, they're obviously trying to send it to somewhere that doesn't belong to you, right? So that you don't see it. And so that's the kind of user journey profiling type of thing that we look at. We do a lot on login as well. That's kind of what, where the focus of the account takeover activity is, as well as payment. We're not looking at credit card numbers, or so there's a lot of people who in the retail purchasing space focus on the actual purchase transaction, credit card, look at credit history and credit information and so on. That's not something that F5, we're not in that space. There's a ton of PII in that. So, the other key thing to kind of be aware of is all this information that we collect, except the IP address, is not it's not considered PII. Obviously, it is, user specific, and we do capture things like hashed user IDs or other types of account information that someone can, use, or we can use to kind of recognize that you're looking at the same account and so on. But we don't really know who that account is. We don't know who you are. We just know that, this particular device or this particular account has been accessed. A bunch of times we don't even know which account it really is, right? So then when we send those recommendations back, obviously the website who we're protecting, they have a whole bunch of other PII information which they can also enhance our recommendations combined with other recommendations, right? So we expect our customers to have multiple solutions in place simultaneously. And those should be, those need to be combined together in their own, even more enhanced recommendations. So some of our customers take our recommendation in and then, use it in conjunction with 2 or 3 other types of protections that as you can imagine would have other information like I said, I always come in on this type of device, or I always come in I filled in some PII information into the form, and that has never been seen before anywhere on the internet, right? So, I go in, I use an address and a email address, and I've never filled that in on any site before. So there's companies who specialize in that type of information, including where I worked previously, TransUnion. So they have that type of information. So they say, oh, hey, billions of times on the internet, you filled in different types of PII together, and do those PII go together, and so on. So you can check that. Or, there's companies like Socure who also kind of look at, what ways that PII has been used in social network data and so on, or BioCatch kind of focuses really on the pure behavioral profiling of how I interact with the website. So again, adding all those together, you get even better protection. So what does a data scientist really do in my team? So there's a whole bunch of things. So, and I have some examples of these that I'll show in a minute, but the first is if you're going to be training a model or trying to answer any questions, you have to prepare and ingest data, in some sort of ETL process, right? So whether it's a new fraud file I got from a customer, whether it's customers will complain about, hey, here's 15 IPs that we think were involved in fraud, and can you tell us more about their activity, or why did you not catch this fraud specifically? So they may ask us questions of that kind. So you got to clean up the data, make sure it's in a consistent type of process. Looks like, let's see if I realize I've not been looking at the questions so far, but so yeah, so let me think what's the best way to handle some of these questions. But yeah,
Rupert, we'll ask them towards the end.
Okay, we can do that. So yeah, so they will send us data. We have to try to match it up is the next thing. After you've cleaned up the data, you got to try to match it to our data set. So all the data we collect goes into BigQuery on Google Cloud, where we use mostly Google tools in our organization. So it goes into BigQuery, it gets all those signals are there. There's billions of transaction results and transaction stages and so on sitting there. So, we have to do some complex joins of those that information. So normally the customer will have provided us like timestamp and IP address, some sort of hopefully we have a common hashed ID of some kind that they provide us and we capture so that we can do a join more accurately. But often you're trying to just combine based on timestamp, or even in some cases by IP address, and there can be our system generates a lot of incremental captures of information in the flow. So in a single flow, you might have 5, 10 different collection points where we're collecting signals. And so you got to figure out which of those is like the best one. So there's quite a lot of, it turns out we don't make it easy for ourselves we don't flatten this data. So in the bot defense side, they have a process that runs every 5 to 15 minutes that flattens all these transactions down into a very nice, clean, simple table. But because we capture quite a wide range of signals and custom features for customers, we leave everything in a raw JSON format. So it's not in a nicely flattened table that makes it very easy to do joins and or investigations. So we have some automated processes to make that better, but depending on the customer, sometimes that that is not generic enough to catch every customer's scenario. And we've been building out that infrastructure a fair amount in the last 6 months to try to make it more robust and standardized, so that the team doesn't have to do a lot of manual data processing. There's often issues. So the signals we capture, you don't capture all the signals in time. You don't capture all the signals in general. So sometimes you look at there and 20%, 30% of the time the signal didn't, that we might have used or think we want to use wasn't captured. There's a certain amount of time that we have to capture data. And so obviously if the data is not captured in time, there's not really much that can be done. It just does, the data doesn't exist. So next thing, after you've got the data nicely joined with the let's say the fraud file that the customer gave us, you're ready to train a model. Or maybe they gave us this maybe the first time you've trained the model, maybe it's you're retraining a model. So this is what people think of as kind of the core of data science. Doing the model training, doing the hyperparameterization, tuning, feature selection, and so on. I'll show you in a minute a little bit more about that piece. And what that looks like. So realistically, a year ago, our team spent 90% of the time on ingesting the data, joining the data, and 10% of the time actually training models. The model training and optimization process is relatively straightforward. The tools are pretty standard, and so not so challenging, other than to if you really want to make your model perform well. And so now we've built more standardization and tooling to do joins and prepare the data from our customers. So the team now spends more time on trying to figure out how to optimize the model, make sure we're actually catching, the fraud patterns that exist, and trying out different model techniques. We tend to use something called XGBoost primarily. That tends to be the primary model training process that we use. Recently, we've been looking at some unsupervised model techniques like isolation forest for anomaly detection. We do build some rules as well. So rules, again, is not really, it's a different sort of process, more a decision tree type of, manual decision tree type of thing, where you figure out some features that you think are important and try to figure out the right thresholds for them. So after you've tuned the model, looked at the performance curves, what's its, false positive rate, what are the thresholds you're going to set, then we work with our customer to deploy the model. So most of our customers, they actually have to approve a new model deployment. And so, this is where kind of doing external data science is definitely very different than internal data science. Because you can't just say, oh yeah, hey, I got some new data and I want to train a model and let me deploy it. We have some customers who say you can only deploy a new model on the last Thursday of the month, right? And they actually have a very specific window at 6 p.m. on a Thursday on the last day of the month, and you have to give them a bunch of different stats about the model. Basically like a week before it gets deployed. And as you can imagine, that's not, that's not very responsive to large and fast changes in retooling by fraudsters. So, the bot side, we have their customers are generally more, flexible in letting us, deploy pretty much any time of day, usually with, a small amount of warning, maybe an hour or something like that. But even there, sometimes they have longer windows. So, and then the team spends a lot of time actually interacting with customers, explaining what we're seeing, why we missed, we might have caught, 5,000 fraudulent transactions last month, but then they tried some hacker tool and they managed to get by with one transaction, and they want to understand why we missed that one transaction. So there's a lot of kind of customer management, especially if you're working with someone who's not fraud teams. Typically, this is where it's very different than sort of the security world. Fraud teams understand that everything that we do is probabilistic, and that I might catch 70% of the fraud, or I might catch 60% of the fraud, and I might have 1% or 5% false positive rate, or 3% false positive rate. Typically the security teams think about this more like, oh, how do I stop everything that I can, and I should have basically no false positives, or very low false positives for a lot of things, let alone, I should be able to implement something in the next hour that stops something. Where the fraud team's kind of like, oh yeah, I understand, like we update this model once a month, or once a week or something like that, and that's just they understand they're always in a somewhat of a losing battle against fraudsters, and they're just doing the best trying to do the best they can. Right. So let's go on and kind of look at some of the actual data types of things that we look at. So so this is a chart that we shared with a customer. So I'm going to show you some actual charts that we shared with customers. So again, as we're kind of training the model, as I mentioned, there's a whole bunch of features. We have about 700 unique features that we've built over time. And they usually have relatively inscrutable names, like, number of blurs, which, if you don't know, so for our customers, we do provide reason codes. So this will give you sort of the top 5 reasons that the model fired. And so this here is showing you sort of the top 10 reasons for a particular model that we built. And we give them a dictionary that says, like, okay, number blur means the number of times that they switch back and forth between browser windows. That's the blur here. Number of invisibility is really about, like, were they using like an invisible window that, doing something that they weren't like actually looking at. And then you have combinations between like runtime IDs and blurs and how many times you see that in an hour, and number of pastes they did, how many pastes they did versus how many runtime IDs they used in an hour. Again, the model finds things, right? And some of them you can explain, and they make sense, and some of them are harder to kind of figure out, like why that might be important. And that's part of the job of data science, is also to hopefully be able to figure out what some of these features meant. And yeah, so I guess back to the 700 features. So if you train a model on 700 features, it will almost certainly do what's called overfitting, which is where the model basically finds a set of features that very specifically catch the fraud that you saw that particular time. But if you had any other fraud, the model is so carefully tuned to the things that it's seeing that it won't find any other examples. So we typically find that 20 to 70 features is really usually the best number to not overfit the data. So that means you have to kind of carefully pick what features you want to use, try different, run the model multiple times with different feature spaces to see what are the features that are showing the most importance, and then finalize your model with the best set of features. The other thing that we've built out is another way of kind of looking at the feature space. So if I have 50 features, how do the patterns of fraud sort of change over time? How does that feature space look like if I kind of flatten it down into into different patterns? And so this is sort of showing you different color-based clusters that have taken the 50-dimensional feature space, flattened it down into a set of different clusters of fraud. And at the bottom, you can sort of see over time how those patterns actually changed. And so between June and July, there you see that the green pattern disappeared. Well, if you look below in the chart, you can see, yep, the green was going along, and then around June 21st, it disappeared. Now, you can argue whether did it become the orange one, did it become the brown one, or did it just get blocked, right? And so in this case, you probably, you might say, and you can obviously, we look at some of the more detailed features to kind of see if we think there's some similarity, but the red one there, on the other hand, you can see that the red group on June 21st dramatically goes down, and there is a now blue pattern that has very similar seasonality. Seasonality meaning, how it changes within a day, sort of the traffic and so on, and the overall amount of volume. So in that case, it looks like they changed a couple of things that they were doing in their attack, and kind of switched to the blue space. And you can sort of see up above that, a bunch of red kind of went away and the blue got stronger, right? And the brown pattern, also, suddenly appears. So, what do some of those clusters actually look like? So taking two of those clusters that I showed before, Shapley value is one of the ways that data scientists sort of explain the importance to the model of a particular feature. So negative Shapley value means it's an indicator of not fraud, and the positive Shapley value in this particular case shows an indication of it is fraud. And then you can also see we've mapped out the color coded this by the importance of the feature value, and then the scale of the amount at that particular point. So if I look at like the number of login attempts in 1 hour, and those are browser fingerprints, you can see that most of the distribution is around 1 in the Shapley value, but it has relatively low value as a feature at that point. But when it's very negative, those have much, or yeah, more on the negative side. That indicates it's not fraud. So so you can what generally happens is the model is now combining all those red pieces together to make a judgment in an individual case. And so we then try to explain what these might actually mean to to the customer about what the attacker is actually doing, right? So cluster 2 is really indicating that they have a lot of pasting and unusual browser type that they're using, and they're using mostly new devices with low device age, which means they're replacing their device ID or using lots of different devices for the attack. While in cluster 4, there is some paste and some uncommon browser, but they have low time on page and minimal keystrokes, right? So that that's kind of and so you can imagine if you went back here that and again, as I recall, those 2 and 4 are the green and the purple categories there, showing you that those green folks apparently disappeared or transferred into brown or orange for some period and then went away. But yeah, and that the purple kind of developed there kind of for a bit in the middle, but was not really there early on and not really there at the end. And then this is a more recent example, which this one does not have that nice, the green suddenly went, or the red went away and the blue suddenly showed up. But it does kind of show you, you can expect fraudsters to different fraud pattern groups attacking at different sort of rates of, they come back, they disappear, they come and go, right? And we definitely, as you do new mitigations, they retool. Generally, as I mentioned before, the goal is to kind of make your customers' site harder to attack than someone else, and then they go away. It's not that you figure out how to completely stop them. It's really that you make it easier or harder than the next guy who might have access. So, in the case of our retail food chain that we were protecting, they were having a huge amount of fraud. We successfully brought that down over a couple of months, and then as far as we can tell, those people switched to using Uber Eats. So it's not that the merchant in the end actually didn't lose the orders, but they stopped losing the credit. They were no longer paying for the fraudulent credit cards Uber Eats was. So in that particular case, it was pretty interesting because we also found that they were discussing and allowing these orders to happen on Discord. So we could actually watch on Discord. They would be like, okay, yeah, we put a new mitigation in place, and they're like, oh, orders are down right now, and then a day later they figure out something and they say, oh, we're back again, or they'd say, oh, sorry, we're no longer taking orders on the site directly, please use Uber Eats. And so Uber Eats was almost always the fallback and seemed to have the lowest level of protections last year. But let's see here. The other types of things that the team works on is experimenting with new types of techniques. So one thing we're working on right now is trying to take some of the fraud patterns that we saw and see. So one thing we see with bank customers is we can train a model that's very specific to the bank. A type of attack usually often lasts as long as there's kind of enough data breach data. So let's say the fraudster has stolen 1 million login credentials. They go and test it on a particular bank. It takes them a couple of weeks to run through those million. Once they finish that attack, they go away. And then they come back like 3 months later, they bought another list and they try again, or they take that same list and they try it on another bank, right? So if we figure out how to kind of stop them on one bank, well, the obvious thing we'd want to do is take that pattern that we've learned from the fraud file from that one bank and then apply it to the other banks so that if they see that same type of attack, they're protected. Now, the problem with that is everyone's website is designed differently, right? And a lot of the things that we capture, these features we capture, are really kind of specific to the way your website is designed. So we have something we call a cross-enterprise transfer model, which is where we take those patterns and we apply it across to another site. If I don't have some way of statistically trying to analyze the pattern of fraud on that other website, or the way that people interact with that website versus how they interacted for the site that I saw that pattern on originally, and then can sort of shift all those thresholds in a somewhat automatic or manual way, that if I apply that model, just without making any changes, there's obviously going to be higher false positives, or could be potentially quite high false positives. So we are working with our customers right now on something we call active learning. So we take the most uncertain transactions from the model that we train somewhere else. When we apply to the new customer, we take a certain set of the transactions that we think are going to provide the most training value. We have put those into our account protection console, which is a console that we let our customers do their own investigations and look at summary information and so on. They can then review those and look at other data they have internally and say, yep, we think you got it right. No, you got it wrong. They can then, we can then feed that back into the model and tune those thresholds, in a more, in a relatively quick way, for customers who, have never seen that fraud pattern before, or don't really have a fraud file, or have a very small fraud file. So that's kind of one of the things that we're, experimenting with right now, as well as trying to take more sophisticated anomaly detection models to find kind of unusual transactions in a uniform way. We find most, unfortunately, in the manual fraud space, for bots, anomaly detection works really well because you tend to have, hundreds of thousands of repeat transactions that are pretty much the same in the way that they're attacking the website from the signals that we collect. In our case, we might have 5, we might have 10, we might have hundreds, generally not, tens of thousands or hundreds of thousands. So anomaly detection becomes much more of a very unbalanced data problem with very few data elements to kind of capture. And so false positives are a real bane, because if you have 1% false positives and your rate of fraud is 0.1%, well, then you're blocking 10 times as many false positives as you're actually blocking fraudulent transactions, which is not a great customer experience and something that obviously our customers don't want to happen. So you have to be very careful with anomaly detections in a manual fraud type of scenario. And it's not to say that we don't also have similar problems with fraud files in the same way. And a lot of customers obviously aren't big enough to have thousands or tens of thousands of examples of fraud, which is really what you want to have to do a good training. And this is just a quick example of kind of like, in account protection console, they can go in, they can look up, they can do manual block lists or allow lists. If they say, hey, you know what, my QA team always uses this set of IP addresses or these device IDs, please, let them through. Or, oh, I saw some phishing going on this device, please, block any further transactions for that. So they can go in and do their own sort of some of their own management. We're going to obviously add more rule building and things for them to do some of their own mitigations. That's definitely a key thing, as well as, give them more interesting reports about, the weirdest ASNs and IPs and devices and geos that we see, we're making recommendations from, just so that they, can decide whether I want to, specifically block anyone from, a particular country. A lot of websites do those kinds of, basic things, like not going to accept anyone from Eastern Europe, certain Eastern European countries, or Nigeria or whatever. So anyway, with that, I think, yep, that's the end of my presentation. So I will take some questions now. So let's see here. So Ken asked about real time. What do I mean by real time? And so do we actually hold up the request or transaction until it's ready? And what is the policy if the remote machine learning is slow or unavailable? So typically, the answer today is no, we don't hold up the request, the transaction. And so that is definitely a key challenge of what often is called a race condition, which is where our recommendation comes back too late for their use of the recommendation. And there's a number of ways around that. You can either set the recommendation trigger point early enough on a form. Let's say there's like 10 things they're filling in the form. Well, maybe after 6 things or 8 things on the form, you trigger you do the trigger, and that means that 99% of the recommendations are received in time. So yeah, our goal is to not block the recommendations, but there are definitely scenarios where we might recommend that they do that. It also means that we're not blocking them from, or the customer experience, if for some reason our service goes down. Let's see here. Ken also asked about, let's see, a lot of these are heuristic. So yes, he does ask, can we do rule-based or anomalies versus some type of cluster? And the answer is yes. That is kind of one of the basic, types of protections that we offer customers is, and because sometimes, the model, you can train the model, and, again, machine learning is not always the most effective thing, because sometimes certain things just you can heuristically decide are just wrong, right? So yes, in that case, one should have an actual. I need to plug in. Move, but you do actually need to, just write a rule and say, yep. They come from, any login from this weird time zone, just block them, because the model may or may not figure that out on its own. Let's see here. I think the next couple. Let's see here. Yeah, so someone asked kind of what happens if we missed the fraud, or we maybe caught the fraud. What ways, or what happens next in that kind of process? Yeah, so kind of depending on, the key thing, and why customers are sometimes more focused on fraud or not fraud, is are they really on the hook for making the customer who was impacted whole, right? So like if someone uses a stolen credit, your card, steals your card, makes a transaction on a website, you obviously contest that, and then your credit card company says, sorry, yep, you're right, and they pay you back. Now the merchant who let that happen is on the hook for that, right? So obviously that's called a chargeback file. That takes 60, 90 days to fully populate, and that whole process to go through. Sometimes it can be 15, 20 days. So at the end of the day, they're on the hook. Until recently, banks were not really on the hook for Zelle transactions, which is why that became a major kind of issue last year, because a lot of Zelle transactions were happening and people were being told, like my father-in-law, he had several $1,000s taken from his bank, and they just said, well, you gave them the he got phished, so they sent him a text while he was doing, saying, hey, we think something's wrong with your account, and can you please type in the verification code that we send you. And so he puts his verification code into the text. They use that verification code. It's the real verification code that's letting them make the transaction. And they're like, well, you gave it to them, it's your fault. At the end of the day, as a consumer, you're like, well, no, aren't you supposed to be protecting me? The money was actually transferred to another bank. That bank has the money, or they should have the money. You should be able to get the money back. So there was some legislation pending, and then the Zelle and the banks all agreed, like, okay, yep, we're gonna. Towards the end of last year, they said, no, we're gonna actually, not make the customer liable for that. And so then, like, he then got, so they had said denied, and then like a month later, 2 months later, they said, oh, actually, we're gonna get you your money back. So he was fortunate that happened later in the year. But so that's kind of the challenge of some of these things, is if you miss them and the order happens, or who's really liable. So do we need, so I have a question here about, do we need to deploy multiple models for a single customer? Yeah, so we do deploy multiple models. It is statistically, in theory, a single model could recognize 8 different fraud patterns really well. Realistically, though, you're probably better off having those kind of split into a couple of different models. We find we do continue to test whether those overlapping models cause more false positives, or as I mentioned before, like maybe you want to have a model that's a cross enterprise transfer model that's got several fraud patterns, or maybe you've got some anomaly detection, unsupervised type of thing model. You've got some rules, and then you have a particular machine learning model. So we do have to kind of identify which model is doing what. Can a customer hold us legally responsible if fraud is not detected? Nope. We do not sign up for those type of SLAs. So there's not we're not on the hook, so that's fortunate. Let's see here. Account opening. So yeah, so someone asked about I referenced account opening on a previous slide. Yeah, so we will train, based on a fraud file comes in, we train a model, and again, like a particular customer might have account opening, they might have account takeover, and they might have money transfer. So those would be 3 different use cases. The behavior patterns for those will be different. So we would have different models for each one of those. And like I mentioned before, depending on the scale of the data and some issues of how the data looks, we might have a different model, and we will definitely have a different date, right? So if I received a new fraud file, the particular customer I was showing there gives us a fraud file every week. As a large bank, has tens of thousands of fraudulent account openings every week. So they have a lot of data, and so they'll be like, hey, we train a new model, we deploy the new model, and we give it a new date name, and then we remove the old model. Let's see here. Sometimes I get calls from bank regarding my transactions to confirm if I'm doing it or not. Is there a human in the loop? How do we determine where and what stages human loop is needed in these detection systems? Yeah, we don't really, that's more really how the customer decides to use these recommendations. So we build these models, we set up the recommendation responses, and then they obviously have to figure out their process for what they want to do with it. So in some cases they block, other cases they review those manually, or have their own workflow where they sort them based on combination with other recommendations they see, and then those get reviewed manually, and then someone actually will call, right? And that could also be the other way around. Like, maybe you tried to make a transaction and then you got blocked. You call up and they say like, "Hey, why was I blocked from making that transaction?" And then the person on the phone will look at, they may go into account protection console and look and see why you were blocked, or they might have that reason codes flow into some other, system like Nice Actimize or something that these guys often use as their workflow tool, and say, "Okay, yeah, you look okay. Let me, go in and allow your account, and you can make that transaction or help them make that transaction in real time," right? So that is not uncommonly, a scenario. It's less common in this day and age now that banks especially actually call anyone, right? They might have an email or something, right? And that gets to, whenever you receive a notice now, they recognize that those have been too much copied by fraudsters. So I don't think anyone sends out automated emails or texts anymore saying like, "We think there's something suspicious." And if they do, you should always just go to the website directly, or, call, go to the website, check what the phone number is and all that kind of stuff. Because there's just too many people phishing and attacking, and have, access. They can spoof, phone numbers and all this kind of stuff. So it's really hard to judge whether anything that ever comes to you is real, but doesn't seem to be anymore, that they've all pretty much stopped. Yes, so Ken was also wondering about, classification or LLMs for our domain space. One type of technique we're definitely working on is GNNs, or graph neural networks. Definitely there's a lot of opportunity to kind of classify communities in our data, and that's something we don't really do enough of yet. So we're definitely doing some research there. Whether LLMs can find patterns, we haven't tested yet, but I'm somewhat skeptical that they'll find anything particularly useful in most of our data. They might in, let's say, account opening or something like that. But again, because we don't get raw addresses or other types of form data, it's kind of hard to imagine we could really, find useful information there. So, but anyway, it looks like we've run out of time. So I thank everyone for their time, and hopefully you all found this interesting.
Rupert, if you have more time, we can take a few more minutes and answer a few more questions,
Okay.
if you have time.
Sure. Yeah. Let's see here. How sensitive are customers to false positives? Yeah, as I mentioned, that is really very variable by customers, and so that is one of the things we do is we tune the model to their particular goals. So there's what's called an ROC curve, which sort of shows you for a given false positive rate, what do we think we're going to actually find in terms of fraud, the recall, as it's called. And so, we'll usually share that with a customer and say, "Hey, are you okay with 1% false positive, or do you really want to get as much recall as possible, and you're okay with 4% false positive?" And that's where we have a second category. We have block, which we think are the lowest false positive, most clearly false, category. And then we would have what we call challenge, which we would recommend to the customer a higher false positive rate, gives them more coverage, they don't block, but then they can either do some kind of further investigation combined with other data sets, or do some type of second factor authentication, additional friction. And so say, okay, yep, this particular case, we should make this person do an extra verification code or something of that nature, just to make that transaction a little bit more secure. So that's a pretty common sort of scenario. Let's see here. How are we modeling? Yeah, so someone was asking about attack patterns. Yeah, API. Yeah, so API-based attacks. We have definitely seen scenarios. We have seen a customer where they were having an API attack. They did not think it was possible. And the way they saw it was they were doing bot protection on the login page, but not on the order submit page. And so we were on the order submit page and the login page on the account protection side. And the number of order submits was actually higher than the number of logins. And so, they clearly recognized there that someone was going straight to the API for the order login page, replaying the login credentials over and over again, and making fraudulent orders, which we were catching some fraction of. So that would be one kind of scenario of an API-based attack. API-based attacks in general, and this is kind of also the same thing with bots, is that APIs often are designed for machines, right? So if it's a machine, the characteristics of a machine are more standardized, more regular, so they're harder to kind of detect in the a lot of the common ways that we do. They are going to look like they're doing lots of pace because it's an automated system interacting with that API. So anyway, so yeah, API attacks are more problematic and are best suited for, I think, network or white or allow list kind of scenarios, because it's more someone is using my API. I've never seen this device before. I've never seen this IP address before. They're coming from an unusual ASN that I'm not familiar with. It's better to kind of create a controlled API with a controlled set of people who are interacting with it, whether it's your own internal systems or a small set of trusted vendors, as opposed to trying to just open up that API to both all comers, whether it's automated access or humans accessing it. So
Rupert, it's a very engaged community. We are recording this session.
Yep.
Perhaps I can help. I can ask you the questions from top down.
Sure.
And if we can answer them, then the answers will be recorded, and the community can listen to all of the answers.
Yep.
So I'm just going to pick the one I see on top. Can you share a high-level view of how models are trained and what is the starting point?
Yeah. So like I said, typically we have a lot of different features. Generally, we have some features that we think are more commonly useful. And so normally we kind of split up the feature space, run a couple of feature tests, look at the feature importance, and then pick the highest performing features. So that's kind of and then there's that's generally the system goes off, does its standard library run. These are Python libraries, so they're pretty commonly used models. So hopefully that gives an idea.
Yeah. Can you elaborate on what types of models you use on the table? I'm assuming this is the BigQuery table, and why you choose the ones used.
Sure. Yeah, I would say at this point, we have not done as much evaluation of like lots of different model techniques. XGBoost is very common for supervised, unbalanced data sets like ours. So that's kind of where we started with that as a technique, because, like I said, that's typically our data is very unbalanced. Fraud is clumpy, very small fraction of data is fraud. So that's
Got it.
That's kind of the basic there. I would say as we continue to hire more people and get more automation into our processes, which been doing a lot of work on over the last 6 months, the team will be spending more time researching other techniques, is what I would say. So we do think graph will have at least to allow us to create what are called embedded features. So the graph techniques don't run fast enough. LLMs wouldn't necessarily run fast enough, but they might, in both cases, create some interesting features. So you can run some features, calculate the features values, and then use those in a table as a embedded feature in your XGBoost model. So
there's a question
to kind of do that a fair amount once we've had more time with graph databases and other techniques.
There's some concern about XGBoost being open source.
Mm-hmm. That's a fair point. I need to go check and see how we're actually doing that, and we'll talk to the security team about what library we're using there. Yeah.
Cool. There's a question about how many models are normally deployed per customer.
Yeah, I think, like I said, I answered that one, so we can.
Yeah. Okay. From Mavula, how is our model different from competitors? Is it something which is first in market?
Sure. Yeah, I think our model techniques are not different. There's kind of two things that we compete on. One is the signals that we capture. So it's really the features and signal space that have come from the 10 years of building the bot defense JavaScript collection, and a number of years on the mobile SDK that allow us to capture a lot of really interesting and unique signals that other people don't have access to. So other people have probably some more sophistication on the mobile side because they've spent more time, like there's people out there who claim that they look at how you walk with your phone in your pocket. So BioCatch, for example, improve, they make all kinds of bizarre claims about things about how you actually interact with your device that, we don't capture those types of accelerometer and GPS signal stuff to build, complex signals around. So it's that kind of thing that people have specialties of signals that they've captured.
Yeah, I think you answered the question that Evan is asking, but for completeness, I'll ask, how are you handling model observability in production? Sure. How is the potential delay between predicted versus actuals when it comes to fraud handled? I think you answered that, but perhaps you want to answer.
Yeah, so just on the model observability, that's one area where it is definitely the case that when you train a model, and based on how you sample the training set and the holdbacks and all this kind of stuff, the real world model performance is definitely not exactly the same as what you predict it to be, right? So we do run periodic reviews of each of the models to see how they actually perform in reality versus what the prediction was, and it's definitely not the same. We've definitely seen that. So that's also something that we did not really have a systematic way of doing that until a couple of months ago. And so But that, our bigger customers expect what we call a quarterly business review, and that tends to be one of the key things they ask us is like, hey, can you go back and look at see how we actually did versus what you predicted, and that that is definitely an important discussion point about, okay, this model doesn't seem to be actually doing as well in production as we thought it was. This other one seems to do better than this other one. So, we continually have to kind of inspect that, and add more, real-time monitoring tools and so on. But yeah, I actually do have to run. So
okay,
this was fun.
Rupert, thank you so much.
Sure.
This was an amazing insight into the work that your team is doing. Data science is not simple, and an impressive number of signals you collect, the team collects, and amazing amount of progress has been made in creating the pipelines to analyze that signal.
Yep.
There are more questions. We'll cover those via email. So thank you so much, Rupert.
Yep. Thank you.